In this video, we will be doing a proof involving overlapping triangles. This proof is a good bit harder than some of the others, so stick with it, you will get it. Given PM is congruent to KG, KP is congruent to GM, prove KM and PG bisect each other at L. KM and PG right here. So let's get to the proof, and we will do it on the diagram up here. So PM is congruent to KG, PM is congruent to KG, given. KP is congruent to GM, also given. KP and GM over there. KM is congruent to KM, that is reflexive property. So for KM, we're going to do this in red, showing it's that whole length over here. Then triangle KPM is congruent to triangle MGK, SSS, side, side, side. We've got all three sides of these triangles. Then angle KMP is congruent to angle MKG, CPCTC. Corresponding parts of congruent triangles are congruent. So KMP over here is congruent to MKG over there. Next, angle PLM is congruent to angle KLG. Vertical angles are congruent. So angle PLM here is congruent to angle KLG over there. Vertical angles. Next, angle KGP is congruent to angle GPM. So KGP right there, and angle GPM over there. The reason for that is the third angle or no choice theorem. The other two angles in these two triangles are congruent, so the third angle must also be congruent because triangles add up to 180 degrees. Next, triangle KGL is congruent to triangle MPL. Triangle KGL and triangle MPL. ASA, angle side angle, two angles and the included side. Then KL is congruent to ML, CPCTC. We're going to do that in green to set it off a little bit more. KL and ML, corresponding parts of congruent triangles, are congruent. Next, PL is congruent to GL, again CPCTC. We'll do it in green to set it off. Those two are congruent. Then, the last step, KM and PG bisect each other at L. Definition of segment bisection. You can see two congruent segments. Therefore, these two segments bisect each other at L.